Hello, once again. Welcome to another episode of THP Tutorials. We will continue with the Management Information System series. This is Chapter 7. So, Chapter 7 is about telecommunications, the internet, and wireless technology, right? Telecommunications, the internet, and wireless technology. Let's take a look at the objectives. So, the first is what are the principal components of telecommunications networks and key networking technologies, right? So we'll be looking at telecommunication networks and networking technologies. And we'll be looking at what the principal components, what are the main components that make up telecommunication networks, right? And the key technologies when we are networking. So that's the first objective we'll be looking at. So for the second one, that's what the different types of networks. Then we'll move on to look at how the internet and internet technology work and how do they support communication and e-business, right? So we'll be looking at what how the internet and its technology works. That's one side. And then we also look at how the internet and and its technology supports communication and e-business, right? E-business as an electronic business on the internet, right? What are the principal technologies and standards for wireless networking, communication, and internet access, right? So, after looking at the internet and the internet technology, what we'll be taking a look now at would be the wireless networking, right? Wireless networking, communication, and internet access. And look at the principal technologies and standards used for that. Once again, this chapter is about what telecommunications, the internet, and wireless technology, right? So the first objective, the second will fall under the telecommunications, the third will fall under the internet, then the fourth is about the wireless technology, right? So let's begin. So let's begin. The components of networks and key networking technology, right? So the components being the principal components. For the first one, we have networking and communication trends, right? That's a component in networks and it's a principal component in networks. Very well. So there's the networking and then the communication trends. And another we have convergence, broadband, and broadband wireless. Now convergence is what telephone networks and computer networks converging into single digital network using Ethernet standards, right? So the convergence is speaking to the networks like computer networks and telephone networks converging, right? When something is converging, it's meeting, right? From different directions coming to meet at the central point. That's convergence, right? So these telephone and computer networks are converging into a single digital network, right? So they are converging to become one single digital network, and they do that by using internet standards, right? So that's what convenience is about. That's what the trend is speaking to. The other trend you have there is broadband. It says that more than 74% of US internet users have broadband access, right? Broadband is simply a means of connecting to the internet, right? You have broadband. And there's what? Broadband wireless. So we can guess that broadband has to do with wires. Then broadband wireless is what? Voice data communication are increasingly taking place over broadband wireless platforms. Right, so with the last one, the broadband wireless is actually speaking to the fact that broadband wireless platforms are being taken over by voice and data communication. Moving the next component. So we see that all these three, this convergence, this broadband wireless, all these points that we just explained, they come under this main component. So networking and communication trends is the first component in the components of network. So it's the first component that I've talked about. And this convergence, the broadband and the broadband wireless is coming under that. Well, and the computer network. There's what? Two or more connected computers. Two or more connected computers. major components in single network. So with the second component of networks, we have the computer networks. And the computer network is speaking of the connection of two or more computers. And the major components in a simple network include what? Client and server computers, network interfaces, that's NICs or NICs, then connection medium, networking operating system, hubs, switches, and routers, right? So this is speaking to the major components that you will find in a simple computer network. Then you have the software defined networking. Software defined networking that also falls under computer network component of networks. And that speaks to what the functions of switches and routers managed by central program. Right? The functions of switches and routers managed by the central program. So these are the various things that we talk about under computer network. So software defined networking falls under computer network. So computer network is the second component that I've looked at. Right, so see, as I was saying, these are the components of a simple computer network. It's being elaborated here, right? So it says illustrated here is a very simple computer network consisting of computers, a networking operating system residing on a dedicated computer server, cabling or wiring, so the wiring connecting the devices, network interface cards, that's the next that we spoke of, switches and then a router. Right, so this is a single computer network. This is a switch, router. These are the other networks on the internet. And this is a server. This is the main server, right? This is the network interface card. The NIC being this orange thing wire, the rectangle. The NOS is the network operating system. Then you see that the network interface card is on the CPU of the PC. So this is the PC. It's another PC, right? So two or more computers connected, right? This switch, this connection so this is what makes the network, right? And these things are what connect the computers to the network. There are more computers that can be connected to the switch as well, but this is just a simple network, a simple computer network. Moving on. The third component is what? Networks in large companies. Networks in large companies are a principal components inside networks, right? So network itself, I'm breaking it down. So now the network in large companies also form a principal part of networks. And it says that here, hundreds of local area networks, LANs, linked to firm-wide corporate network. Those are the networks in large companies. So that large companies imply that they have many subsidiaries or many branches. So in each of those branches, they are LANs or local area networks, right? And they are linked to firm-wide corporate network. So that's what connects the networks LAN. So the LANs is different LANs. They are all connected, right? By the firm-wide computer network. So the firm-wide computer network is made up of these hundreds of LANs. Very well. Now various powerful servers. So this is another point on the networks in large companies. Right. So in these large companies too, there are powerful servers, right? Such as websites, corporate intranet and extranet. Right? Intranet and extranet is the same as internet. But with intranet, the company or a firm will personalize it and only give access to people inside the organization. With the extranet, it gives access to people inside and outside the organization, right? Like so, outside the organization, we'll speak to individuals like the suppliers, customers, and other relevant, people. Very well. So under these large companies, too, in their networks, we have mobile wireless LANs, Wi-Fi networks, right? And video conferencing system, telephone network, and wireless cell phones. Very well. So these fall under what? Networks in large companies. So this is an illustration of the corporate network infrastructure. Right? We have today's corporate network infrastructure. It's a collection of many different networks, from the public switch telephone network to the internet to the corporate local area networks, linking work groups, departments, or office floors. Right. So these are the things that you're talking about: the phones, the telephone system, right? So the telephone service provider, the internet service provider, wireless internet service provider. That's the Wi-Fi network. This is the ISP. So that the servers are what the corporate website, intranet and extranet. That's where all the information is kept, right? And these computers, I'm guessing, will be clients. Yeah, these are all clients on the network. And there's a wireless LAN, right? So this is just this is an illustration of what a corporate network infrastructure would or should look like. Moving on. Also, part of the components of networks, we have what key digital networking technologies. So with this one, it speaks to client or server computing, right? What's client or server computing? Let's see. So client server computing is a distributed computing model. The clients are linked through network, right? So the clients linked to the network controlled by, so the server or the network server computer control the clients on the network, right? So the clients request information and then the server gives it or serves them. So yes, that's what the server sets rules of communication for the network and provides every client with an address so others can find it on the network. So every client is assigned an address by the server, right? And the server also sets the rules of communication. Now, client server computing has largely replaced centralized mainframe computing. The internet, the largest implementation of client server computing, right? So the internet is the epitome of what client server computing is, right? It's the best example. It exemplifies what the client server computing is all about, the internet, right? Moving on. So still under the, see that here you have what key digital networking technologies. We have continued. So the client or server computing is the first point under the key digital networking technologies. Oh, look. Right, so the networking technologies also form a component of the networks. Right here. So the components of networks and key networking technologies. Right. So how do I explain it? So at this point, see, look why digital networking technologies, right? Networking technologies. Now see, components. So this is the objective that we are handling right now. Components of networks and key networking technologies. Key networking technologies. What does this mean? You're looking at the components of what network and key networking technologies. So what we can state here is that what the networking technologies, which are the technologies used to network, are also principal components under networks. However, the key networking technologies also have their own components. So that could be, so you can tell out those components are subcomponents of network. So at this point, we are breaking down the networking technologies. We are breaking them down. And the first was what the client server computing that I just explained, right? Now the next component in that, the key digital technologies is what? Packet switching. So with packet switching, is a method of slicing digital messages into parcels or packets, sending packets along different communication paths as they become available, and then reassembling packets at the destination, right? So let's say you are sending a message to someone, maybe a long letter about your birthday, about application for a job or something. When you whatever you are sending, when you send it from your device, the packet switching, what it does, if you are on a network, that's the scenario. On a network, this is how it works, right? So this networking technology is you send your message, right? Your digital message. Before it's not sent as a message like this to whoever is receiving it, right? The packet switching breaks it down into packets or parcels, and then transfers those packets to the receiver. Then when it gets to the receiver, it is reassembled into the original message and then displayed over there. So that's what packet switching is about, right? So you slice data messages into parcels or packets, right? Then you send those packets along different communication paths as they become available. And then you reassemble the packets at the destination. Now, the previous circuit switch networks required assembly of complete point-to-point circuit. So this is saying that previously it was what circuit switch networks, right? And they required assembling complete point-to-point circuits. But I think with that one, how those ones work is that what it wasn't really looking down. The complete circuit was assembly of complete point-to-point. Very good. So with the circuit switching, it simply means that what there is no slicing, right? What is sent is just sent to whoever is being received the way it is, right? That's what I think the circuit over here means. Now packet switching more efficient use of network communications capacity, right? So the point here is that when it comes to the capacity of a network's communications, packet switching is the more efficient choice, right? It serves the organization more efficiently. That's what we are saying, right? So this is an illustration of what the packet switching networks and packet communications look like. Right? Data are grouped into small packets, which are tran- transmitted independently over various communication channels and reassembled at their final destination. So see here, packet number, message number, destination, right? This is the entire message, right? So this whole thing is the data, right? You write out. So I didn't elaborate now. See, so according to this diagram, what happens is that you take this data, you send it down different communication paths. So packet one is is on a different route, packet two is on a different route, packet three is on a different route. And when they get to this point, they are reassembled to that message. Then they are displayed at the final destination, right? So that's how packet switching works. Right now, still under the key digital networking technologies, we have what the TCP slash IP is a protocol, right? And connectivity. So this TCP IP is an internet protocol, and it's what is a transmission control protocol, internet protocol. But what's a protocol? A protocol is a set of rules that govern the transmission of information between 2 points, right? A protocol is a set of rules that govern the transmission of information between 2 points. Now, as we already spoke about this, the transmission control, the TCP IP. So the TCP slash IP is what a common worldwide standard that is basis for internet. So it's the basic or the foundational protocol for the internet. Now, the Department of Defense reference model for TCP IP, the TCP Internet Protocol is one about 4 layers. So the Department of Defense, the reference model that they propose is what a 4-layered model of TCP IP. So you have the application layer, the transport layer, the internet layer, and then the network interface layer. Here is an illustration, right? So this is a reference model for communications by the Department of Defense. So you have the application layer, computer A, computer B. They both have the same protocol, right? So they have the same rules for communication. So this is how it works: application interface, transport, internet, and network interface. Computer A, computer B. Right? So this is an illustration of what the reference model of the TCP internet protocol looks like. So at this point, we are done with the principal components. So let's quickly, recap that. It's very dense. So another component, the first we had was what? We had networking and communication trends. That's the first one. And then that we have what? The convergence, the broadband wireless. So these are networking and communication trends. Very well. Very well. Computer network. What's a computer network? You have two or more connected computers. The major components. So computer network is the second one. These are the under it. So the first one was what? Networking and communication trends. Computer network. Networks in large companies. Then we came to what? The digital networking technologies. So the network of the components of network are four. Right? The first was what? The trends. Second was the computer networks in large companies. And then the networking technologies or the key digital networking technologies. Right? Very well. Now, under the key digital networking technologies, these are the points that we have. So, we have the client server computing, packet switching, and the TCP IP and connectivity, right? So the transmission control protocol, internet protocol, which is a common worldwide standard for the internet, right? And we talk about the layers it's hard. Now we're looking at what? Different types of networks. Very well. So here it says what? Signals, right? There's the digital versus the analog. What's a modem? A modem translates digital signals into analog form and vice versa, right? So here, when you're talking about networks, we have signals, right? So the signals are not the types of network, but I think, well, as you are progressing, we'll break that down. So see, modem. The modem is what? Translates digital signals into analog form. So what the modem simply does is that it translates digital signals to analog form and vice versa. So you can also translate analog signals to digital form. What are the types of network? The local area network, the wide area network, the metropolitan area network, and then what? Campus area networks. So LANs, WANs, MANs, and CANs. Right. So the types of networks are what? LANs, WANs, MANs, and CANs. Or can man can LAN man one? So I'm not joking. Put it here. Mans cans one LAN. Mans cans one's LAN. So just make something with that. The C is for campus, M is for metropolitan, the W is for wide, then the L is for local, right? So another local area networks have the Ethernet, Ether, no alcohol. Ethernet, you see that there are cables that are used to connect the internet. If you have a laptop, you can check if you have one. It's so it looks like the telephone cable. That's the internet cable. Now, there's also the client server versus peer to peer. Anyway, let's break that down. So this is just speaking to the functions of the modem, right? How does the modem work? The computer, this is a computer. They are all on a network, right? So this computer will send digital information. Modem converts it to analog. So analog is what? It's in a waveform. Don't forget that. When the modem is here, then digital 101010 computer. So that's how they communicate. So the modem is used to communicate, right? The modem is a device that translates digital signals into analog form and vice versa, so that computers can transmit this data over analog networks, such as telephones and cable networks. and the different types of networks, right? Here you're talking about. So if I'm speaking about the types of computer networks, this is, I think, let's see what it is. Physical transmission media. So physical transmission media, and then I have twisted pair wire at 5. Coaxial, coaxial cable, fiber optics cable, wireless transmission media and devices. So there you have satellites and cellular systems. And there's transmission speed. I think these are, should I say, terminologies, concepts, or things that we should know when we are talking about networks, right? So transmission speed like this, bits per second, hertz, bandwidth. Right? These are all network language, so it's easier for us to know. So this is how we measure transmission speed on the network. You can measure it in the bits per second, the bps. We always see that on your mobile phone, right? Then there's the hertz and the bandwidth, right? So the physical transmission media, I think, how does a network transmit data? And I think these are some of the things that it is used. The twisted pair wire, the coaxial cable, the fiber optics. As for fiber optics, is where that speed the internet. Those are high speed cables, right? And the wireless transmission media and devices, satellites, cellular systems, right? Very well. So that's it for the types of networks. So you just remember that a modem does what? Converts digital signals to analog form and vice versa. That's one. And the types of networks are what? Mass, LANs, WANs, and CANs. And then other relevant things that you should know is the physical transmission media, like these ones, and the transmission speed. How we talk about the speed on the network. There's a bits per second, bps, hertz, and bandwidth, right? So moving on to the next objective. That's what the internet and internet technology. So the internet is the world's most extensive network, right? You have ISPs, the internet service providers. What do the internet service providers do? They provide connections, right? Types of internet connections. Dial-up 56. Sorry. So the internet is the world's most extensive network. Fine. Internet service providers, the ISPs. What do? They provide network connection. Very well. Now, what are the types of internet connections? There's a dial-up, there's a data subscriber line, the DLS. Then you have what? Cable internet connections. And you have satellite. T1, T3 lines, right? So remember we are talking about network speed. Talk about bps, bytes per second. Right? So the dial-up appears to be rather, well, that's 56.6 kilobytes per second. I think that's the speed with dial-up. That's not very good, right? Then the digital subscriber line, which is better than the dial-up because it has up to 10 and its range is between 10 and 85 kilo bps to 40 megabytes per second. So that's better. Then you move to the cable, which now deals from it ranges between what 1 and 50 megabytes per second. When the satellites, they do it 1.54 to 45 megabytes per second. So the one with the largest range is what? The cable internet connections, which is 1 to 50 megabytes per second. Those are the different source of internet connections and the speeds that they deal with, right? You know that the internet is the epitome of what? Client-server computing, and these are all networks. So the internet is a connection of 2 or more computers worldwide. Well, so the internet in itself is a network. You can make that inference. Right, so this is why we spoke about the transmission speed over here, so that it has come in handy, so you can calculate these things. Right, so internet addressing and architecture. Now, each device on the internet is assigned an internet protocol, an address, right? Each device on the internet is assigned an IP address. So that's what we're saying that what the internet is the largest example of what client server computing. In the client server computing, the server makes the rules of communication and assigns an address to each client. So the internet has its server, and that server assigns each device on the internet or each client what an IP address, right? Then there's the domain name system, that's the DNS. And what the DNS does is that it converts your IP address to domain names. There is hierarchical structure, ranks, power past power, and top level. So there are also top level domains. So the IP address, well, it says what? It's a 32-bit number. So let's look at this one. This as well. So this is an example of an internet address. It's 32 bits. Let's count the numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 3, 3, 3, 9. So 11 numbers. There are 1 dot, 1 dot, 1 dot, 1, 2, 3. So 3 dots between them. So 32 bits. So study this somewhat. 3 numbers a dot, 2 numbers a dot, 3 numbers a dot, and then 3 numbers at the end. Right, you can come in your objectives. Moving on. The domain name system. The domain name system is a hierarchical system with a root domain, top level domains, second level domains, and host computers at the third level, right? So this is what we're talking about, where this domain system, where that converts the IP addresses to domain names. That's a hierarchical structure. There are top level domains. Apparently, there are also what second level host computers. Right? So this is the internet root domain. So this is the root, the beginning of life. These are the top level domains. Edu, that's for educational. I think commercial, government, or organization. Net means something, right? So now you break that. So these ones are broken down into what second level domains. So you have, for example, have Expedia, you have Google, government, looking out to Congress, right? And the third level domains, that's where the host reside. So sales.google.com, computer1.sales.com, .go.com, and this computer one sales. Right? So that's how the domain name system works. See, what did you say it does? It converts the IP address to domain names. So this is a domain name. Right. So still on. Oh, this was about what? Oh, this one was about internet addressing and architecture. So this spoken mainly about the addressing. So yeah, you are talking about internet architecture and governance, right? Network service providers. So network service providers own trunk lines, high-speed backbone networks. High-speed backbone networks. Then there's a regional telephone and cable TV companies. They provide regional and local access. Then there's the professional organizations and government bodies which establish the internet standards, right? So this is speaking to the governance of the internet and how it's provided, right? So we have network service providers and they are high-speed backbone networks. So they form the backbone of networks and they are high speed. So trunk lines are the backbones of the network, and a network service provider will be an organization that owns a trunk line, right? So that's how they can give people access to the internet. And the regional telephone and cable TV companies are what they provide regional and local access, right? But then there are also professional organizations and government bodies which establish internet standards. So that's IAB, ICA, and then there's the WC3, right? These all stand for something, right? Well, so the And these are the professional organizations. So the IAB stands for what? The Interactive Advertising Bureau. ICAN is what? The Internet Corporation for Assigned Names and Numbers. And W3C is World Wide Web Consortium. Very good. Now let's look at the future of the internet, right? IPv6 and the internet too. IPv6 has a new addressing scheme for IP numbers, right? Or your IP address. And it provides more than a quadrillion new addresses. So that's new addresses for computers on the internet. Now, not the IPv6 is not compatible with the current IPv5 address. Right? So it's not compatible. Very good. Now, the internet too is it has to do with advanced networking consortium. Right? So universities, businesses, government agencies, and other institutions. Right? They develop high capacity. That's 100 gigabytes testing network and testing leading edge new technologies for internet. So the internet 2 is testing leading edge new technologies for the internet. It's also developed high capacity. That's 100 gigabytes per second of testing networks. Right. So there is also an advanced networking consortium. So it has to do with universities, businesses, government agencies, and other institutions. So that's the future of the internet, right? IPv6 and internet too. Here you have internet services. So internet services include email, chatting, and instant messaging, news group, telnet, file transfer protocol, and World Wide Web. So those are the services offered on the internet. Right, so you have understand the internet is the epitome of what? Client server computing, right? It's a good example or an embodiment. It's the internet, it's the client. The client is us, right? Whenever we are using the internet, this is us. Web browser, other client software, whatever, right? So this is us. This is the internet. Now this is what the internet is made up of. There is a server. We have the HTTP server, the simple mail transfer protocol, the domain name serving utility, the file transfer, the FTP, network news transfer protocol, right? All these are on the server. This is the application server, this is the database server, this is the back-end systems, databases. Comes down to what? Sales, production, accounting, human resource. In the server too, so the server also has web pages, so has what? Mail files. So depending on what you want, you can just choose and retrieve. Anyway, so this extends to here, here, and here. This is a client or server computer on the internet, right? The client's computers running web browser and other software can access an array of services on servers over the internet. These services may all run on a single server or on multiple specialized servers. Right, so the server can either be one or multiple. So I think that these are still under the internet services. Right, so your emails, that list that your all this is a continuation. Voice over IP. That's the voice over internet protocol. Right, that's why the O is small. Voice over, not voice over. Voice over is one word. Right, with this one, digital voice communications using IP, packet switching, right? Providers, cable providers, Google, Skype. Right, these are the providers of the VoIP services. Then there's the unified communications systems that integrate voice, data, email, and conferencing. Then there's the VPNs, then the virtual private networks, right? We all know what the VPN is. So that's with secured encrypted private network over the internet, VPT, tunneling, among others. So how does voice over internet protocols work? Here on the internet, have a user, this is a gateway. How are you? ABC. It's sent, right? So So this is what the packet switching is talking about. So there's packet switching involved, right? So the ABC is for how are you. The XYZ is what fine. I'm fine, thank you, right? So you send it. It's spread across different parts, right? So the packets are switched. Then when they get to the destination, they are reassembled. BCA, but it still counts as what? You see that it's not really arranged well, but the message is received at the end. How are you? Right? So it's same. So the same process too. It passes through the gateway, comes out, or the packet switching takes place. Then they are reassembled at the final destination, right? See, a web phone call digitizes, digitizes and breaks up a voice message into data packets that may travel along different routes before being reassembled at the final destination. A processor nearest the a processor nearest the call's destination, called a gateway, right? So this gateway is a processor. Arranges the packets into the proper order and directs them to the telephone number of the receiver or the IP address of the receiving computer. And this is a VPN, right? So a VPN is a private network of computers linked using a secure tunnel connection over the internet. It protects data transmitted over the public internet by encoding the data and wrapping them within the internet protocol by adding a wrapper around a network message to hide its content. Organizations can create a private connection that travels through the public internet. Very well. So this is the tunnel that they're talking about, right? So everything that passes through this tunnel is encrypted, so it can't be seen. That's how a VPN works. The data is going, data is coming. Right? Now here you have the web. Let's go back and check. This were internet services. So now I'm talking about the internet services. I'm talking about the web. And the web, you have what? The hypertext markup language. That's the HTML. They have the hypertext transfer protocol. And these two, HTML and HTTP, are the communication standard used for transferring web pages. Now, uniform resource locators, that's the URLs, addresses of web pages. So the address of a web page is called a URL. This is an example. Web servers are software for locating and managing web pages. So web servers simply locate and manage. So they are softwares that locate and manage, or they are used to locate and manage web pages. Also, now you talk about search engines. Now, so these can all fall under the internet technology, right? So the services, the web. Now I'm talking about search engines. These are all technologies. Now, search engines, they started as simpler programs using keyboard indexes. Google created page ranking system, right? So we have mobile search. 50% of all searches in there. So in 2014, 50% of all internet searches were from mobile phones. And there is search engine marketing, there is search engine optimization, there is search engine algorithms, right? Like Google's Hummingbird, which came in 2013. Then there's a sentence evaluation and then the knowledge graph. Right? These are all things that the internet comes with, right? So web search engines in the US, Yahoo, this is Yahoo.com. That's where 10% of the searches come from, right? So Google is the most popular search engine, handling nearly 70% of web searches in the United States and 90% in Europe. So see, most people use Google. There are others 2%, not that relevant, right? Then there's Axe.com. There's Yahoo. And there's Microsoft. I think that's Microsoft Edge. right? How does Google work? This is one, two, three, four, five, and six, right? So there, how does Google work? You take your phone, you are searching for something. So how does Google work, right? The user enters a query, you ask a question, right? So the user is any one of these devices. User, you ask a question. And the Google's web servers receive the request, right? This is the web server, it receives the request. Google uses several million pieces linked together and connected to the internet to handle incoming requests and produce the results. So here we come what? The request is sent to the Google index servers that describe which pages contain the keywords matching the query and where those pages are stored on the document servers. Right, so your keyword, the word that you type, they scan through their web pages and look for the pages where those keywords can be found. So what? You use PageRank software. The system measures the importance or popularity of each page by showing an equation with more than 500 million variables. So they evaluate all the web pages that have everything, that have those keywords, and they rank them in order of popularity and other factors. And then small text summaries are prepared for each web page. So they see that when you say the summaries come. So you read small, read to and choose the one that's best for you. Then the results are delivered to the user. 10 to a page. So every page has 10 results. Then you scan through to get what you want. Very well. So that's how Google works. So still on the internet, there's social search. That's efforts to provide more relevant results by including pages visited by users' social network. Google One, Facebook Like. So the social search is about what? Efforts. The internet wants to provide more relevant results, right? So they include the pages that you have visited, in your social network. So they use Google plus one and Facebook Like do that, right? And then there's semantic search. That's anticipating what users are looking for rather than simply returning millions of links, right? So there was something when I type in and they give you options. Yes. So intelligent agent shopping bots. They use intelligent agent software for searching internet for shopping information. So these are all technologies and services on the internet. So they are all just funny to you. So that's how we categorize this one. Social search, semantic search, internet agent shopping bots, how Google works, search engines, all these things. They are simply there's technologies or services that the internet is providing. Right, then you have Web 2.0. That's the second generation services. It's enabling collaboration, sharing information, and creating new services online. Right, the features: interactivity, real-time user control, social participation, and then user-generated content. Right, so that's what. So Web 2.0 is also a technology on the internet. Let's not get it twisted. Right, so that's that Web 2.0. Now, Web 2.0 services and tools, right? It's a technology. What are the services and tools that it comes with, right? It has blogs, it has wikis, it has social networking sites. So yeah, for the blogs, there's the chronological informal websites created by individuals. Then you have the RSS. That's a really simple syndication, right? The syndicates, so what the RSS does is that it syndicates web content. So aggregator software can pull content for use in another site, in another setting, or viewing later, right? So it saves some of the information that you see, so you can easily view them later. Sometimes it even automatically downloads it for you. And there's a blogosphere and there's a micro blogging, right? So these things fall under the blogs. And there's wikis, right? Collaborate. So what's a wiki? A wiki is a collaborative website where visitors can add, delete, or modify content on the site. right? Social networking sites, right? They enable users to build communications of friends and share information, right? So the social networking sites, they enable users to build communications of friends and share information. So these are all the services and tools that Web 2.0 has, right? And there's a Web 3.0. It's called what? The semantic web. Here we have a collaborative effort led by the W3C to add layer of meaning to the existing web. Goal is to reduce human effort in searching for and processing information, making web more intuitive, increase communication and synchronization with computing devices and communities. Internet of Things, visual web, increase cloud computing and mobile computing, right? So the semantic web, it was a collaborative effort. I think it was led by the World Wide Web Consortium, and they added a layer of meaning to the existing web, right? So you try to reduce the effort that we use when you are searching for and processing information, right? It makes the web more intuitive. Very well. So we are looking at the technologies and standards for wireless networking, right? We are at the last objective, right? The last but not the least. So we want to look at the technologies, right? And then the standards for wireless networking. So the cellular systems, let's take a leap and say it's speaking to the technologies, right? So cellular systems. And then we have competing standards, CDMA, that's for the United States only. And there's a GSM, right? The rest of the world, AT&T and T-Mobile. With the GSM, you sit on your mobile phone if you look often, right? So these are the competing standards. Now you have third generation networks, that's 3G, and they range at 144 kilobytes per second. They are suitable for email access and web browsing. For the fourth generation networks, well, they go up to 100 and 100 megabytes per second, right? And they are suitable for internet video, right? So you play the 4G when you are using your internet, when you're watching your videos, maybe YouTube and alright, on social media and stuff. We have 4G and then 3G. Wireless computer networks and internet access. So yeah, the first was cellular systems. Right? Cellular usually has to do with what mobile phones, cellular. So this is how wireless networking works on the phones, right? We have 4G, 3G, you know what these things are. And the computing standards. So we have so I think the standards here is what the CDMA and then the GSM. So these are the standards. Now another technology is what? Wireless computer networks and internet access. So the first was what? Cellular systems. These things that we spoke of were under the cellular systems. So wireless computer networks and internet access. We have Bluetooth 802.15. It links up to 8 devices in a 10-mile area. No miles, it should be meter. 10-meter area using low power radio based communication, right? And it's useful for personal networking, PANs. There's also Wi-Fi, which is what? 802.11. That is a set of standards. So the standards is the 802.11. And it's used for wireless LAN and wireless internet access. They use access points, right? So device with radio receiver or transmitter for connecting wireless devices to a wired LAN. So they use access point. And an access point is a device with a radio receiver or transmitter. So that's what an access point is. An access point is a device with a radio receiver or transmitter for connecting wireless devices to a wired LAN. So a Bluetooth network, PAN, right? Personal area networking. So personal networking rather. Bluetooth enable a variety of devices, including cell phones, PDAs, wireless keyboards, and mic. Wireless keyboards and mics, mouse, plural, PCs and printers to interact wirelessly with one another within a small 30-foot area, right? 10 meters. In addition to the links shown, Bluetooth can be used to network similar devices to send data from one PC to another. Bluetooth can be used to network similar devices to send data from one PC to another. For example, we do the example, right? Network, cell phone, printer, wireless keyboard, user computer. They are all connected to each other using what? It's Bluetooth that is connecting them, right? Very good. They can send data to each other. So on the wireless computer networks and internet access. So that's a continuation of the first point. So it's 1 point. So we still have 2 points, which is what? Cellular systems and wireless computer networks and internet access. So Wi-Fi. So this is more information on Wi-Fi. So hotspots. Now hotspots, there are one or more access points in public area to provide maximum wireless coverage for a specific area. They have weak security features. Right? It's easy to hack into someone's Wi-Fi. Now when you say WiMAX, that's the A standard is what? 802.16. Wi-Fi is 802.11. Very good. So the WiMAX is a wireless access range. It has a wireless access range of 31 miles. So it works within a 31 mile radius. 31 miles radius. And they require WiMAX antennas. So they require antennas. And another technology is what? So this is not a technology that I'm talking about. The radio frequency identification, the RFID. This use tiny tags with embedded microchips containing data about an exact item and location. Now tag antennas. So these tags, they tag antennas to transmit radio signals over short distances to special RFID readers, right? And then the readers send data over network to computer for processing. The common uses are automated toll collection, toll booths, and the tracking goods in a supply chain. So it's used in business. Now see, so what's the RFID card? So there are tiny tags which are embedded in microchips, and they contain data about an item and location. Now the tags, they tag antennas to transmit radio signals, right? They transmit radio signals over short distances by tagging antennas, right? And they are transmitting the radio signals to special RFID readers, and those readers send data over network to the computer for processing, right? And they require companies to have special hardware and software. Reduction in cost of tags, making right. So now the cost of the RFID has reduced. So now many firms can afford it. It's a viable option for them. And so this is the tag, right? So this is a microchip inside there. With the tiny tags embedded in microchip. So this is the microchips, and that's the tag, right? The radio waves. I sense the reader, and the computer accesses it. accesses it. So the RFID uses low-powered radio transmitters to read data stored in a tag at distances ranging from 1 inch to 100 feet. The reader captures the data from the tag and sends them over a network to a host computer for processing. Right. So this is a tag, this is a reader, this is the host computer. So this microchip holds data including an identification number. The rest of the tag is an antenna that transmits data to the reader. So this is actually the antenna and it's transmitting the data. This is the data it's transmitting. Now this reader also has an antenna that constantly transmits when it senses a tag. Right? So whenever it senses a tag, and it will detect it, right. It also interrogates it and it will decode the data. Then it transmits the data to a host system over a wired or wireless connection, right? So the host computer will then process the data from the tag that has been transmitted by the reader. So it's used to track items. So maybe you have vantage points that or checkpoints. So that you install the readers at those checkpoints, and then when the item that you're tracking passes that checkpoint, the reader will pick it up, right? Because they are always transmitting the data. So when it picks it up, it will pick it up to also interrogate it and then it decode it. After decoding the data on the tag, it will send it to a host computer, and that's where you can track uh, you can track the item and know how well it's doing. So this is our next point, right? The wireless sensor networks, WSNs, right? And they are networks of hundreds or thousands of interconnected wireless devices embedded into a physical environment to provide measurements of many points over large spaces, right? So wireless sensor networks. So there are networks of what? Many wireless devices, right? And these wireless devices have been embedded into a physical environment. And what they do is that they provide measurements of many points, so over large spaces. So they could be temperature, less one. So they are used to monitor building security, right? They detect hazardous substances in the air. They monitor environmental changes, traffic, or military activity. So that's what they do. Many hundreds, thousands of wireless devices. We embed them in a physical environment, and they simply measure things or spot things, right? So you can use them to monitor your security, track substances in the air, or monitor the changes in the environment. Right? These devices have built-in processing, storage, and radio frequency sensors and antennas. Right? So they have sensors and antennas built in, right? And you are capable of processing and storage. They require low power, long lasting batteries, and ability to endure in the field without maintenance. So they can go a long time without being maintained. They are major sources of big data and fueling Internet of Things. Right? So big data, we already have a video on that. So just check that out and all will be well. So this is an example, right? It's a wireless sensor network. So small circles represent lower level nodes, and larger circles represent high end nodes. Right? The lower level nodes forward data to each other or to the higher level nodes, which transmit data more rapidly and speed up network performance. So this is just the area, right? These are the lower nodes. They are connected to what? High nodes. These are the high nodes. What do the higher nodes do? They receive data from the lower level nodes, right? And they transmit the data more rapidly so that that speeds up the performance of the network. Right. So let's quickly go through, right. So when you talk about the technologies and standards for wireless networking, it begins with what? cellular systems. You have your wireless computer networks and internet. So and internet access. Radio frequency identification. And wireless sensor networks. So these four. Those make up the technologies and standards for wireless networking. That's all for this video. Thank you very much for watching. Please don't forget to like and subscribe.